Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tear, and this is my continuing feature on the Math Lovers book. I haven't done this for a few days. What I'm doing now, I decided instead of doing this feature every day, like I've been doing most of this year so far, I'm going to do it probably every other day from now on. And I'm going to interleave this feature with a new feature I'm running now called Daily Math Problems because I think those are a little more fun than this. I mean, this is sort of an academic feature, what I'm doing right now. I'm going through, the first two volumes of this three-volume series I wrote from 2019 to 2022. And, right now, for the last all year, I've been doing volume one, which is the more recreational of the two first two volumes. The third one is Problems and Solutions, by the way. I'm not going to go over that. If you want to do them, I encourage you to buy copies of these books. They're available both in paperback and Kindle format on Amazon.com in case you're interested. You can either search for my name, David Tear, or the title of the series, The Math Lovers book. Anyway, that's my pitch. But anyway, like I was saying, I'm doing another feature called Daily Math Problems. I did that for the last couple of days. I'm also doing weekly live streams every Thursday evening from 6 to 7 Pacific Standard Time, which is the time zone I live in here in Las Vegas, which is also, I think, 2 to 3 a.m. Greenwich Mean Time. Probably not convenient for most of you guys in Europe, but in Asia it's morning time. It probably is convenient for people in Asia or in North America or South America, I guess. But anyway, enough of that. So anyway, today I am continuing my feature on logic, and I'm starting a new section now, section 7.3, which is on predicate logic. I just did several videos on propositional logic. Um, and predicate logic's a little more complicated. It's very similar to propositional logic. It's actually a little bit richer. It involves something called quantifiers. I'll just jump in here. So I explained this in this introductory slide. I explained what predicate logic is. Remember, in propositional logic, we just had simple statements, atomic statements, which we just represented by a single letter. Well, now we're going to, a single capital letter. Now we're going to put small letters next to those capital letters. And those small letters are what are called predicates. And you can think of them as adjectives. So you can kind of think of the sentences as, just, a simple sentence like, I'm in my office. But then, you could add a quantifier like, I'm really in my office. Or, I mean, maybe that's not a very good example, but, like you could say something like, I like apples. That could be your statement A. But then you could say, I like green apples. So you could A sub G or something. Anyway, I'm just going to show you some examples of this. So, yeah, I don't think I start with the examples right away. Maybe I just should because probably easier to understand what's going on if I give you some examples. So, yeah, so here's my examples. I have three of them in this chapter, and I hope you guys can read this. I realize that this is going to look very small, especially if you're using your cell phone, your smartphone, which most people seem to do these days. If you're on a computer, you might not, or a tablet, you might not have so much trouble. But anyway, I'm just going to go through these examples. So suppose we want to, and these are just examples of how to express a statement, compound statements, as using predicate logic. So for the first one, we were asked to use predicate logic to represent the statement John is an engineer, but Fred is not. Well, let's just look at each of the atomic statements. This consists of two atomic statements. John is an engineer. Um, and John is our subject, and engineer is what's called the predicate, which is sort of like an adjective that describes what John is or who John is. So we could use a little, yeah, I guess John. Actually, the subject is the thing we put in. Yeah, so engineer is our predicate, and then we want to quantify it by who's an engineer. So we would say capital E sub J. That means John is an engineer. I guess capital E kind of represents the class of all people in the world who are engineers, and so some people are engineers, some people aren't. So when we say John is an engineer, we're kind of quantifying the class of all engineers, and we're saying this person named John, which we're representing by a letter small j, as being an engineer. So we write capital E sub j for John as an engineer. But then to say that Fred is not an engineer, we can quantify Fred with a letter small f, and we can write capital E sub f. That would mean Fred is an engineer, but we're not saying that. We're saying Fred is not an engineer. So we would put a not. Remember the not symbol? That kind of funny looking, looks like a minus sign with a little hook at the end. You put that on the left. So you would say E sub j for the first part of our statement, and, because we're using and in our sentence, not E sub f. That would be the symbolic way to represent that statement. And for the second example, we want to use predicate logic to represent the statement spring follows winter and summer follows spring. Well, now our predicate is follows. Yeah. And then our subjects are spring and winter, spring, and summer. So this time we have three kind of subjects in this statement, or objects, I guess. When you say something follows something, it actually needs two predicates. Now, actually, winter, spring, and summer are our predicates. I'm sorry, I'm messing this up as usual. But following is the verb. Yeah, the way you're supposed to think of this, I didn't explain this well. Let's back up. Our capital letters are verbs that are waiting for subjects to be attached to them. A verb doesn't mean anything by itself, but like being an engineer is a verb. Either you are an engineer or you're not an engineer, and then you can quantify that by saying John is an engineer or Fred is an engineer. And similarly, to say that something follows something, you would say you would use the letter capital F maybe for follow. That's a verb, and then A has to follow B. I mean, it doesn't have to be seasons. It could be other ordered things like a birthday party follows a birthday. Or object following follows you letting it go. Whatever you want, as long as the second thing comes after the first thing, then we would say A follows B. And so that's true for seasons of the year. Spring follows winter. So we're using capital F for our predicate, and now or no, not the predicate, the subject, and then the predicates are winter, spring, and summer. So we would say we could represent spring follows winter as FSW. I mean, it might be a little clearer if we write SFW, but we don't write it that way. We always write the quantifiers to the right side. Or not the quantifiers, the predicates. So the right side of the subject. So we would write capital F, and then we have small s, small w. That means spring follows winter. And the second part of our statement is summer follows spring. Unfortunately, spring and summer both start with the same letter of the alphabet. So we have to write, and we have to use a different letter for summer. I'm using U because U is the second letter, the first letter after S, if you like. So we could say summer follows spring as F sub U S. F, capital F, small u, small s. So our statement becomes capital F, S, small w, and then the symbol for and, the upside down A without the line through the middle, and then we have capital F sub u sub s. So that's the way we represent that statement. Spring follows winter and summer follows spring. And then I have just one more example on the bottom here. How would we say Paul drinks soda and beer? We have to have our verb in this case is drinks, and we could use Paul as the subject. He's the guy who's drinking. And the third thing, the small letter next to Paul, in this case, would be what he drinks. So we could say Paul drinks soda is capital D, small p, small p for Paul, and small s for soda. And similarly, we could say Paul drinks beer as capital D, then small p and small b. So finally, when we combine these, we would get capital D, small p, small s, wedge, upper wedge, and capital D, small p, small b. That means Paul drinks beer. So anyway, that's how you would represent compound statements in predicate logic, and we're going to use these. And then everything after this. I mean, the only other new thing. I may as well give you a little bit of a heads up here. The only other new thing I'm going to talk about in this section is quantifiers. That's going to come next. There's two quantifiers. There's for all and there exists. And for all we represent as an upside down A, and there exists as an upside down E. I'll get to that next time. And then we'll have all the tools in place. We have to add a few rules of inference, but then we'll have all the tools in place to do arguments and predicate logic, as well as in propositional logic. And that's basically all of Boolean algebra. So once you know how to do predicate logic, you pretty much know how to do everything in Boolean algebra. So I'm going to give you all the tools to do Boolean algebra completely, if you're interested in that. Anyway, that concludes my video for today on predicates. So thank you for watching. Long live math, and I'll see you guys next time. Bye.